So far we have seen EIGRP, basic, intermediate and advanced topic. Now this is another advanced topic in EIGRP, configuring EIGRP for IPv6. You remember EIGRP is a layer 3 protocol, meaning it works in network layer. Now the network layer itself is different here. There it is IPv4 header. Here it is IPv6 header. The header is not the same. Yeah, so the protocol is also not the same. Though protocol name is EIGRP, though it has been developed by Cisco, it is two different module. EIGRP for IPv6 is different from EIGRP for IPv4. It is not the same algorithm, it is not the same module. What I am trying to say is IPv6 EIGRP need to be enabled, whereas IPv4 EIGRP gets enabled automatically. IPv4 EIGRP gets automatically enabled when you go on, say, router EIGRP autonomous system 10. EIGRP start working. If you do the same command here in IPv6, IPv6 won't be available for you because you have to provoke IPv6 module of EIGRP. Fine, let us see what is this chapter telling us about configuring IPv6 EIGRP. Differences and similarities we are going to see. This is the first topic. And then we will see one example, basic configuration of EIGRP. And then we will do EIGRP summarization, but this time it is for IPv6 summarization. And then we'll do some verification. So this is our plan. Overview of EIGRP for IPv6. EIGRP for IPv6 uses IPv6 prefixes. That itself is a big difference, right? IPv6 is what length? 128-bit length. IPv4 is 32-bit length. So definitely the mask is different. Length is different. To establish EIGRP for IPv6 neighborship, EIGRP will use link local address. We don't have the concept of link local address in IPv4. Do anyone remember what is link local address? We learned this in CCNA IPv6 class. What is link local address? Or at least do you remember how it looks? How it starts? How the IPv6 link local address will look like? Okay. Link local address is only for neighbor discovery. Only for neighbor discovery. And it will always start with FE 80. The link local address will always start with FE80. And this address is dynamically generated. Whenever you give a global unicast address, the link local address gets generated dynamically. So this link local address is only for devices to discover each other dynamically using ICMP version 6. And that address, link local address, will always start with FE80. And this is dynamically generated. Though it is starting with FE80, every port, every device will have a unique link local address. How is that possible? By using MAC address, it is possible. See, MAC addresses are unique. So when you take a MAC address attached to this FE80 and generate a link local address, then the link local address will also be unique. Did you understand link local address? So this is one big difference between 4 and 6. In IPv6, EIGRP neighbor discovery happens using link local address. Next, EIGRP uses built-in authentication feature of IPv6 protocol rather than a protocol-specific authentication implementation with IPv4 to guarantee message authentication. Yes. See, in IPv6 header, which is an extendable header, you have an built-in authentication. Whereas for IPv4, it is a separate attachment. It's not within, it's not built in. So in simple, if you need to say, IPv6 have got inbuilt authentication feature, which is not seen in IPv4. We do have authentication in IPv4, but it's not inbuilt. It's externally attached, additionally attached. Next, to transport routing information, EIGRP for IPv6 encapsulates IPv6 prefix in the IPv6 message, not in the IPv4 packet. All right, all the routing information advertisements are kept inside the IPv6 header itself as an IPv6 message. Of course, it is IPv6. No? It should not be in IPv4. I already started by saying IPv4 module is separate, IPv6 module is separate. So definitely IPv6 won't use IPv4 packets. Next, IPv6 has no concept of classful network, correct? In IPv6, we don't have class A, class B, class C. So there is no concept of classful network. So when you use EIGRP for IPv6, there is no automatic summarization at the class boundaries. Correct. There is no automatic summarization. The only way to summarize IPv6 advertised prefix is manual summarization. So we have to do summarization going under the interface manually. No automatic summarization in IPv6. Because it's not possible. Why? Because there is no class. When there is no class, then there is no classful boundary. Next, if IPv4 address is not configured on the router, it's a very important point. This point is very important point. If IPv4 address is not configured on a router, EIGRP for IPv6 requires a EIGRP router ID before it can start running. Yes. See, IPv6 EIGRP needs an IPv4 format address as a router ID. Understand this. This is just a router ID, not the address that EIGRP IPv6 will advertise. IPv6 EIGRP IPv6 prefixes தான் அட்வர்டைஸ் பண்ணும். அப்ப எதுக்கு IPv4 வந்துச்சு? இது சும்மா ஒரு ஐடி 32 பிட்ல ஒரு ஐடி வேணும் EIGRPக்கு. EIGRP for IPv6 needs a 32-bit ID. That ID automatically EIGRP will pick from the interface if you have any IPv4 address. But if you don't have an IPv4 address, we have to manually provide a router ID. We have to manually provide. If you don't provide, it will try to take automatically from the loopback or the physical interface, if you don't have a loopback, an IPv4 address. IPv4 address that router ID எடுக்கும். IPv6 will not take another IPv6 address as a router ID. It needs a 32-bit IPv4 format address as a router ID. Next, EIGRP for IPv6 under a specific interface intended to send and receive routing protocol message. In EIGRP for IPv4, you can configure interface under routing protocol configuration mode. EIGRP for IPv6 under a specific interface. You know what it means? We go to the interface and enable EIGRP, which is not possible in IPv4. Which is not possible in IPv4 EIGRP. You have to go under the router mode and say network. Match this with the interface, then run on the interface. So we used to put network command. You remember EIGRP? You say router EIGRP 10 network blah blah network blah blah. Only then those networks that matches on the interface will be running EIGRP. Those interfaces that matches the network will be running EIGRP. Whereas in IPv6, you don't go under router EIGRP and only go straight to the interface like we used to do in OSPF. Go straight to the interface and say, I want this interface, whatever the address the interface may have, I want it to be in EIGRP process. Right, now we all know that there is a multicast address for a EIGRP to send the hello packets. In IPv4, we call it as 224.00.10, correct? EIGRP multicast address. In IPv6, also it is 10. 10 is A. Instead of 224.00, we put FF02. So this is the dedicated multicast address only for EIGRP. This is the address to which hello packets will be sent and received. Do you have any question? Major differences between IPv4 and IPv6 so far? Do you have any question? Here it is IPv6 message. This is a payload. Routing informations, which is nothing but updates, route updates, are carried as a payload, carried as a data. Here it is just carried inside this IPv6 header as one of the field as a message inside the header. This address FF02::A. That's the important point here. Now we see a topology here, and in this topology we have IPv6 networks, many. I can see 1, 2, plus 4, 6, 7 networks. Yeah, 7 networks we have. So we are going to configure similar like this. We are going to do a lab similar to this with 7 or more networks. But before that, we need to learn something. What is that? First thing is in IPv6, if you wish to enable any routing protocol, without fail, you should type this command in the global mode. Without typing this command, there won't be any neighbor discovery. Now, this command is very important for any sort of routing. In IPv4, we don't do this because in IPv4, IP routing command is enabled by default. IP routing command is enabled by default. But for IPv6, it is not enabled by default. So the router is not a router unless you put this command. The router is not a IPv6 router. It will start acting as a router for IPv6 only after you put this command. Till the time, you can configure it will accept the IP address but not any routing protocol. Without putting this command, if you try enabling EIGRP or OSPF or BGP, it won't accept your configuration. REAP, it won't accept your configuration. As soon as you put the first line of configuration, IPv6 EIGRP, it will throw error. And it will clearly say that you have to put this command. Why? Because this command only enables the routed mode. Otherwise, it will be just like on host, IPv6 host. It won't become a router. It won't join FF02::2. FF02, FF02::2. This is the multicast address called routed multicast address. In IPv4 at a world, it is 224.0.0.2, routed multicast. So when you put this command FF02::, when you put this IPv6 unicast routing, all the ports of the router will start using this FF02::2 that makes a qualified router. All right, let me show you. That makes the router to be a router. All router multicast. So the equivalent of this one is FF02::2 in IPv6. All router local network segment. So this is enabled only when you put that command IPv6 unicast routing. What happens when we configure the command IPv6 unicast routing? See, when you put this command, that FF02::2 will get enabled. That is what I want to show. I don't want any other stories here. It says it enables IPv6, blah, 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 but I want that precise FF02::2. Yes, it uses ICMP version 6. FF02::2. You see, all router multicast group is FF02::2. So this is what actually happens when you put the command IPv6 unicast routing. I'm sorry about this. I'll show you in the lab. Okay, so don't forget, before you enable any routing protocol, you should give this. Without giving this, trying to enable a routing protocol will not work, and router itself will tell you to put this one. Okay, after that, if you don't have any 32-bit IP address on the router, like an IPv4 address on the router, then you need to manually give like this. Go under IPv6 router EIGRP CI, note the point, IPv6. EIGRP router ID, give any number. This 32-bit number need not to be there on any interface. You can give any number of your own. It need not to be a valid even IP address. It can be any 32-bit address. It is just an ID. And without fail, you have to type the command no shutdown. Yeah. This is a, we know that we need to type no shutdown. Yeah, you know, but where you used to type no shutdown? Under the interface. But where am I asking you to type this, you know? Under the EIGRP mode. Here, you need to type no shutdown, not under the physical or logical interface. You need to type this no shutdown command in order to enable the IPv6 EIGRP process. Okay, so three things are important in EIGRP to do. One, you put this command. This is for all protocol. No, number two, you need to provide a router ID if there is no ID to dynamically pick. Number three, you should say no shutdown. Okay, and then this is what I was talking to you. You go straight to the interface wherever you want to run EIGRP IPv6, go and mention it. That's it. There is no network command and wildcard mask concept. You go to the interface after you provide the no shutdown and the router ID. You come out of this router mode and go to the interface and say, this EIGRP I enabled, EIGRP 100. I want that EIGRP to run on this on Ethernet 00 and on loopback 0. All right. So as soon as you enable this, automatically the link local address of these interfaces will start talking and discovering neighbor. All right. You see, this is not a link local address. This is the global unicast address. This is like a public address that which we use to communicate. But to reach that, you see the next stop is a link local address. I told you link local address will start with FE80. You see how the neighbors are discovered. Neighbors are discovered using link local address only, not this address which human being used to ping. In the routing table also you can see, in order to go to this network, this is the link local you need to go. This is the address of the next router, the link local address. This is not configured by us. This is dynamically generated FE80. All right. Don't worry about this if you do not know. But those who have attended my CCNA IPv6, you know what this means. This means that this colon is the zeros. And 64. This is just to read read the IP address. Okay, this is the summarization. Okay, this is for summarization. Listen carefully. One here, so it is one here, and then two here, so it is two here, and all zero. So these all are zeros. Okay, this zero is this zero, and this zero is this all zero. Now this zero is this zero, and this one is all zero and one. This zero is that zero, and two is this all zero two. Now, how can you shrink it? How can you summarize? Summarization is very simple. Now, you want to match only with, if you want to summarize, you match up to here. Up to here, all three are having the same. So 64 minus, this is actually slash 64. Slash 64. Slash 64 minus 2 is 62. That's why you have 2. This is the summary of this. Summarization is nothing here. Simple. எதெல்லாம் காமனா இருக்குதோ அது வரைக்கும் ஒரு வெட்டு பாருங்க, இதெல்லாம் காமனா இருக்குது, அது வரைக்கும் ஒரு வெட்டு. இந்த ரெண்டு பிட்டும் சேர்த்தா 64, இந்த ரெண்டு பிட்டையும் கழிச்சா 62. அவ்வளவுதான். இது 64 எப்படி தெரியும்? இங்க தான் தெளிவா சொல்லியிருக்கிறான், ஸ்லாஷ் 64. ஸ்லாஷ் போட மறந்துட்டான், அவ்வளவுதான். ஸ்லாஷ் 62 இங்க போட்டிருக்கோம் பாருங்க. So summarization is made easy. How do we do summarization? Manual summarization. You go under the interface and say IPv6 summary address EIGRP 100 is the autonomous system number, and I want to summarize like this. I'll do and show you. Okay, so let us first do an IPv6 3 loopbacks for summarization. Next, between R1 and R2, I'm going to take 2000 colon 12 colon slash 64. 64. That means here it is going to be colon 1, and here it's going to be colon 2. Same way here, colon 2, colon 3. And next, between router 2 and 3, it is going to be, I'm just going to assume it as 23 network. Okay, and then I want to have a loopback on R2. I would like to simply say 2222 colon 2. Likewise on R3. colon 3. Right, this is our topology. I'm going to start configuring one by one. First with the IP address, and then EIGRP. I'll start from router 3. You see, to put the IPv6 address, you don't need that command which I was talking to you, IPv6 unicast routing. You don't need to do that. You can put IPv6 address. Oh no, what I did not do is We didn't put v6. Okay, now listen carefully. Listen to my words. I gave an address. Is this starting with FE80? No, but do show IPv6 interface brief. You can see an address starting with link local address dynamically assigned. I only configured this, but this is automatically generated and given. And this address is going to be unique because this is using one of the IPs of the physical interface. Sorry, virus of the physical interface for this. Next. Before I go further, I want to show you again on F00, administratively down, no address, nothing. Those who are new to IPv6, the command to see this interface is show IPv6 interface brief. If you know IPv4, wherever you used to type IP there, you need to put IPv6 here. For example, show IP route is to see the routing table in IPv4. Here you need to type show IPv6 route. First I'll say a no shutdown and then I'll show you interface F. No shutdown I have given. Now I want to take you to the same place. Do show IPv6 interface brief. Do you see any link local address? No. But the moment I give 2000:23:3/64, the moment I give this one, you will find along with this address a link local address. Do you follow me? We have given IPv6 address on this router. I don't want to do anything more here. Let's go to router 2. Interface loopback 0, IPv6 address. Listen, I'm inside loopback 0. I'm giving IPv6 address 2222:2/128. Because it's a loopback, I'm giving 128. I can also give IPv4 address. This is called dual stack. You can give on the same port, I have two addresses. But to verify, you have two different commands. Show IP interface brief will show you only 1.1.1.1. Show IPv6 interface brief will show you this one. Okay. So I don't want to give actually 1.1.1.1. I want to change it to 2.2.2.2 because it's router 2. Interface loopback. You know why I'm giving an IPv4 address? Tell me why I'm giving an IPv4 address. Correct. EIGRP will use it as a route ID. IPv6 EIGRP. So on F01, I'm saying no shut. I put IPv6 address 2000:23:2/64 and interface F00 no shut IPv6 address 2000:12:2/64. All right, done. Now moving on to the next router, router 1. Interface loopback 0 IPv6 address 2000:ABCD::1/128 loopback 1 128 loopback 2. The subnet is 2. Okay, now what? Interface F00, IPv6 address 2000:12:1/60. No shit. Okay, now we have IPv6 address on all three ready. But we need a routing protocol to learn routes from the remote router. For example, if I go to router 3 and check show IPv6 route, I don't see anything other than the connected. On the loopback, this is connected. Sorry, this one, loopback. This is on the physical port. So I cannot ping any other router's network. I can't because there is no route. We need a routing protocol. Now I'm trying to enable EIGRP, see what happens. IPv6 router EIGRP 10. What does it say? IPv6 routing not enabled. This is the command we need. IPv6 unicast routing. After this, if you put this command, no complaints, no complaints. Next, we have to give router ID because there is no IPv4 address on this router. So I'm giving 3. Next, we must say no shutdown. Then get out of here. Go to the loopback and say IPv6 EIGRP 10. That's it. And then interface F00. Same command. How super cool it is, you know. Easy, right? Plain and simple. Let's verify. Show IPv6 EIGRP interface. These are the two interfaces that runs IPv6. Show IPv6 EIGRP neighbor. No neighbors because we have not configured R2 yet. Let's go to R2. IPv6 unicast routing. IPv6 router EIGRP 10. No shutdown. I am not giving router ID here because I have a loopback with IPv4 2.2.2.2. Now going to the interface range command, loopback 0, F0/0-1. I'm going under all these three interface. IPv6 EIGRP 10. That's it. Now you're going to see neighbor. Look at this. You already saw a neighbor. And neighborship is formed using a link local address. Now go back to router 3. Check the routing table. You got a route to reach 22222 via dual algorithm EIGRP. And you see it is pointing towards the link local address of the router 2 F01. Let's go and check that. Show IPv6 interface brief for F01. You see this link local address ending with 6. There also you will find 6. Yep. Now moving on to router 1. IPv6 unicast routing. IPv6 router EIGRP 10. I pretend as if I forgot to give router ID. I forgot to give router ID. I say interface range loopback 0-2 in 0, 1, and 2, comma F00, IPv6 EIGRP 10. You see, I have configured EIGRP, but when I check show IPv6 EIGRP interface, no interface. Why? Very clearly it says why. Because there is no route ID. So either I have to give an IPv4 address to any of the interface, or I have to go to IPv6 router EIGRP10 and say EIGRP router ID. Now EIGRP will come up. You see, immediately it has found a neighbor. Now going to router 3 to check the routing table, I can see all the network which is behind R1. So if I try pinging this loopback, which is loopback 2 of router 1, I'm able to ping. Not even a single packet dropped because IPv6 discovers neighbor before you ping using link look. Now, what is next? I want these to be summarized. I want these three to be summarized. So I go under router 1, interface F00, IPv6 EIGRP 10, IPv6 EIGRP 10. Okay, now IPv6 summary address for EIGRP 10 2000 : ABCD : DAD. I just want to summarize like this. So this is only 48-bit. 48-bit. 16-bit plus 16-bit plus 16-bit. 48-bit. Now if you go to, see, it's summarizing. Now if you go to router 3, instead of seeing these three, you should see only one ABCD. One ABCD, one DAD. You see, you got only one. The summarized one, 48. That's how I summarized. Right? Let's check the neighbor now. Show IPv6 EIGRP neighbor. You have a neighbor. Neighbor is identified using link local. Next, show IPv6 EIGRP topology. You can see topology table with reported distance as well as the feasible distance for each network. Any questions? Same timer, see? Show IPv6 protocol, it shows that EIGRP is running and the administrative distance same. For external it is 170, for internal this one, and then the hello timers all are same. The K values are same. Timers are same, 5 and 15. There is no difference. And let me sniff a packet and show you the multicast address is FF02::A. FF02::A. You see, EIGRP hellos are sent to FF02::A. You can see it here. : A. Right, and the EIGRP is again same 18, but this is an IPv6 header. You see, EIGRP, Cisco EIGRP. This is what it is carrying as a message. It is carrying as a TLV, not as a packet. It is not going as a payload. It's part of IPv6 header itself. Right.